Hi everyone, let us solve a very interesting question from the chapter Work Energy Power. The question says, a force F bar equals B times y I cap plus x j cap divided by x square plus y square newtons, where B is a constant, acts on a particle as it undergoes counterclockwise circular motion. Counterclockwise means anti-clockwise circular motion in a circle x square plus y square equals to 16. They want the work done by the force when the particle undergoes one complete revolution. Means by the time the particle comes back, what will be the work done by the force? Options are given as 0, 2 pi b joules, 2 b joules and none of this. Now, some of you may think, since the particle is coming back to the same position, you may think displacement is 0 and therefore work done will be 0. That is not the case, remember, because the given force is actually not a conservative force. And if the force is not conservative force, then work done in closed path will not be 0. Only for conservative forces, work done in closed path is 0. So let us see how to find the work done. So here is the given force, which is a function of x and y, and this is the path, which is a circle x square plus y square equal to 16. Now you know from maths that equation of a circle is x square plus y square equals to r square. So if you compare this, 16 should be r square. So the radius of this circle will be 4, right? So this radius of this circle is 4 and the center is at the origin 0, 0. Now, how do you calculate work done by a force when the force is a function of x also, y also? The general formula is work done is integral fx dx plus integral fy dy, right? Now, what is the x component of the force? This formula can be written as minus by divided by x square plus y square I cap plus b into x divided by x square plus y square j cap, right? So you can see this is the x component of the force. So integral minus by divided by x square plus y square dx. And your y component of force is bx divided by x square plus y square dy. Now this looks like a very difficult integration, right? Because here we have to do integral with respect to x, whereas here you have y also. So what we should do now, they have to give you the path. Well, actually path is given. This is the path, x square plus y square equal to 16. So from here you should find y. What will be y from here? X square will come this side, 16 minus x square, then square root you have to do. Then that y you have to substitute here and then you have to do the integration. Imagine it will take lot of time if you do this way. So now I will discuss a wonderful shortcut to solve this question by using something called polar coordinates. Now usually when they ask coordinates of a point, we represent it as x comma y, right? And we draw perpendicular to x-axis and draw perpendicular to y-axis. Then this x and y represent what we call Cartesian coordinates. But there is another way of giving coordinate of this point, and that is called polar coordinate. What do I mean by polar coordinate is you don't give this x and y but give this distance r. Now, if you give only this distance r, then this point is not defined. Why? Because if you draw a circle with radius r, all the points will have same r, right? So in order to define this point uniquely, you need to also give this angle theta. So if you give me this angle theta and this r, then this point will be defined. You will know where is this point, right? So this r comma theta is what is called polar coordinates. Now, can we relate the Cartesian coordinates with polar coordinates? Obviously, this x is r cos theta, right? Hypotenuse into cos theta is your adjacent side. And this y can be written as hypotenuse, which is r into sin theta. So this is the formula between polar coordinates and Cartesian coordinates, right? Now let us see how to solve the problem using polar coordinates. So remember, this was the force given. What was x in terms of polar coordinate? R cos theta. And what was y? R sin theta. Right? If I substitute this here, my force vector will be B minus y is your R sin theta I cap plus x is your R cos theta j cap divided by, and in the denominator x square plus y square can be directly written as r square, isn't it? Now notice one r you can take, this 2r you can take common and then cancel with this r. So your force vector will now look, let me write separately in terms of x and y component. So b sin theta by r I cap plus, this minus is there, I missed the minus sign, right? Plus b cos theta by r j cap. Now let us try to find displacement in terms of r and theta. So this particle after some time will go here. So this line will turn by a small angle which I write d theta, and this displacement is your ds, and that ds can be written as r d theta. Now how to find displacement vector? X component times I cap plus y component times j cap, isn't it? So to write this displacement vector, I have to take two components. So one component will be here, one component will be here. If you look carefully, this angle was theta. So this is also theta. So this is 90 minus theta. So the horizontal component, the x component will be ds cos 90 minus theta. Cos 90 minus theta is sin theta. So x component will be ds cos 90 minus theta, which is sin theta, times minus I cap, remember, because it is along negative x-axis. And this component will be ds. Opposite component is usually sin theta, but here the angle is 90 minus theta. So sin 90 minus theta is cos theta times j cap. Now what is ds? R d theta. So we can take ds common. Right, and what is ds? I have shown here already, r d theta. Now to find the work done, we should just take force dot displacement, right, vector, force displacement cos theta, which can be written as dot product, and then we have to integrate, isn't it? Now whenever you write a bar dot b bar, how do you write? Ax bx plus ay by. So x component and x component should be multiplied. So remember, this is the x component of force, this is the x component of displacement along with rd theta. Don't forget that rd theta. Okay, so it will be minus b sin theta by r into this x component, which is minus minus will become plus sin square theta, and here rd theta plus. So this is the x component of this into x component of this, you have to multiply. Of course, there will be integration sign here, right? Plus y component of this into y component of this. So that will be b cos theta by r into cos theta will become cos square, and this r d theta. Very nice. Now you observe, this r gets cancelled, this r gets cancelled, b comes out, and here I can take b common because b is constant, and will come out of integration. I will get sin square theta plus cos square theta, and d theta is also common, and we all know this is 1. So b integral d theta. Now we need to come from which angle to which angle. Remember, your integration variable is theta, remember, and the question was work done in one complete revolution. So if you start from here and come back in the same point, your angle will start from 0, let's say, and come back to what angle? 360 degree, which is 2 pi radian. And integral of this will be theta, put upper limit and lower limit, you will get b into 2 pi. So a very complicated integration was converted to such a simple integration with the help of polar coordinates, right?